So welcome back to our second class for the practical. This time we are going to check through our volumetric analysis. That is quantitative analysis part of our practical chemistry. Now, what we are going to be expecting for this Waec 2025 is we have been provided with our acid sample and our base. So our acid is hydrochloric acid, HCl. So we can know we have our HCl here, and our base is sodium hydrogen carbonate. This is a strong acid and this is a weak base. So we know that the reaction between acid and base is neutralization reaction. Now, we are going to be writing our chemical equation and balance it during the exam. Now, look at it here. We have our HCl plus sodium hydrogen carbonate. This is in aqueous state. This is in aqueous state. When they react, we get sodium chloride in aqueous state plus water, which is liquid, plus carbon 4 oxide. Now, so this is liquid and this is a gas. If you check the ratio, everything is in ratio 1. So the number of mole of this is 1 to 1 to 1, 1 and 1, and this is balanced directly. So we don't have any problem. So the type of indicator that we're going to be using for this type of titration is suitable indicator is methyl orange. Now, when we are doing our titration, we are expected to carry out our titration between acid and base and getting our titer value. It is very important to get your accurate titer value. So, if you have your teacher, your chemistry teacher in your school, and is running you through the practical chemistry for this between acid and base, there is a particular other value that you are expected to get based on the kind of environment where your titration is carried out. So another value is expected to be closer to the value of your teacher.
Yes.
Now, the difference between your subsequent readings should not be more than 0.2, like 0.01, 0.1, and 0.2. And that should be the gap between your teacher's titer value and your own titer values. Now, let's come. Now, when you are now done with your titration, you carry out, you draw your table. In this table, this is where you need to be very meticulous, be very careful, so that you can get your all 8 marks. And calculating your VA, getting your 2 marks, taking 10, you can get your complete 10 marks as a bonus in practical chemistry. What do you do? Now, let's start. Here, when you are starting, you write, this is what you are going to start with. You are using the burette and the pipette. Our burette is calibrated with 50 cm cube. Now, write the calibration, burette capacity 50.002 decimal place cm cube. Your pipette capacity 25.00 cm cube. Indicator you are using, you write the indicator used, methyl orange. Now, draw your table, titration table. Now, in your table, you have the first column, second one, third, and fourth. So, in this first one, write burette reading in cm cube. Final burette readings in cm cube. Initial burette readings, cm cube. Now, coming here, you write the volume of A used, because your solution A is expected to be an acid. But if it is not, they might say solution A or D or K. So here you write volume of K used if it is solution K. If it is Y, volume of Y used. But now let's assume it is A. So you write volume of A used. You put your unit, cm cube. The cm cube here cuts across all this line. The same thing here, the same thing here. Now, coming to this part, you write your first titer, second titer, third titer. The question is, why don't you put rough? Normally, we commonly put rough titer here. And during the practical chemistry in your exam, so your best effort, your best concentration, your best focus, your best capacity, sometimes you will demonstrate and you put every of your best in your first titration. So it is possible that the first one you are going to carry out will give you the best results. Now, when you now do the first and get the best result, that means you can't throw it away as your own, because until you do the second and third, to now give you the clue of exactly what you are going to take. Now, when you start the first reading from 0.00, second 0.00, third 0.00, that they won't penalize you. It is allowed. Now, let's say I ran my own, I got 27.00. When I started from 0 again, I got 26.90. Now, here I got 26.80. So you cannot get 26.95 here. It's not allowed. You can get 26.85. Only what you can get is 27.00, 26.90, 26.80, or 0.70, 60, 40. So all this, the second decimal should be in 0 place. Now, if I now want to pick the two best readings here, I will look for the most concordant readings from my 3 readings here. But sometimes I will ask, okay, I don't want to start my own with 0, 0, everything. So I want to change this one to, let's say, when I've done it, I want to put this one to 2.00, make it 2 decimal place. So simply what I'm going to do, I know that this 2 that I'm having here is my initial for the second titration I'm doing. And what am I going to do? And this is my answer. When I say my final minus initial, it must give me this. Are we together? Yes. So 2 plus 26.9. That means I'm going to get 28 here. Yes. So I'll get 28.90. My 28.90 minus 2.00 will give me 26.90. I'm still correct. So let's say here, I'm now using 3.00. So if I'm adding 3 plus my 26, what am I getting? I'm getting 29.80. So 29.80 minus 3.00 will give me 26.80. So now, I will now come to this my readings here. Let me select. I have 27.00, 26.90, 26.80. My readings are concordant. Now, I can pick the first and second as my best readings. And I can pick the second and third. So the difference between 27.00 and 26.90 is 0.1. So the difference between this and third reading is also 0.1. But for my own, at my own discretion now, I want to pick the first and second. So I'm picking the first and second one. I will now come and say average volume of A, not as you do, average volume of A used in bracket V is first titer plus second titer. What is my first titer? 27.00 plus second 26.90 divided by 2. So now this step is very important. Write this out. Now insert the values, the figures here. Now get the addition of these 2, put it here. Now divide it by 2. Now get your answer 20.95 and put your unit CMQ. So this one will give you your complete full mark, 10 marks bonus in your titration. Now when you are done with this, and your own titer value must correspond with the titer value of your chemistry teacher in your school. So for my students, their titer value will be corresponding with my own titer value. And for your own titer value, let it be corresponding with your teacher's titer value. So you have to work in cooperation with your teachers. So let your teacher tell you, this is the titer value, this is correct, and this is wrong. So for you to pass and haste your titration, acid-based titration practical, so you need to cooperate with your client, with your chemistry teacher in your school. So that is very important. So we have different kind of formula that we're going to be using to do our calculations. So we are used to having CAVA over CBVB equals to NA over NB. Examiner wants to know what is C, what is V, what is CB, what is VB. Our CA is concentration of acid use. Write it out. Just create a part in your booklet. So our CB is concentration of base use. Our VA is volume of acid use. While VB is volume of base use. Our NA, number of moles of acid use. While NB, number of moles of base use. Anywhere you write CAVA or NANB and VAVB, they will know that you've told them already. That is the meaning. The meanings are there. Now, we can still use other things. We are used to writing conc in DMQ, conc in CMQ, and mole per DMQ and gram per DMQ. So what is conc? Concentration, right? Yes. Write it out that the hint concentration equals to conc. So anywhere you repeat conc, they will know you are talking about concentration. So we have this formula that says concentration in gram per GMP equals to concentration in mole per GMP times molar mass. In other words, this concentration in gram per GMP is our mass concentration. So you can say mass concentration equals to this concentration in mole per GMP is molar concentration equals to molar concentration times molar mass, depending on the question they are asked to do. So we have this formula here, N, which is number of mole, equals to concentration times volume in GM cube. Don't forget that this is in GM cube. So, and we have these two mole that will be giving us mass over molar mass, our common formula for our units. So this formula is very useful for calculating our solubility. Now we have CV, C1, V1 equals to C2, V2. From there, when we are doing serial division to calculate our solubility, it will be helping us to deal with some questions. Let's take notes of our formulas and write it perfectly. So to address all questions that will be coming out in our practical chemistry in 2005. And with this knowledge and the proper studying and understanding of the concept, we should be able to ace our exam. Thank you for that.